Chapter 17 is on carboxylic acids and their derivatives. This is the first part for that narrated lecture. So carboxylic acid are a compound that has a carbonyl group bonded to an OH hydroxide, and the general formula is RCOOH. Look at the learning objective. Mostly compare, contrast the structures of carboxylic acid, esters, and amides. And I will ask you to simply name the carboxylic acid and the rest using the IUPAC, not the common names. Ester, they have a OR prime group bonded to the carbonyl atom group, and amide, they have a nitrogen atom, so NH2, NHR prime or NR prime twice. Primary, secondary, or tertiary. How do we get there? Well, acid anhydride are formed when you have two carboxylic acid that are joined by eliminating a molecule of water, so that's a dehydration. This is here the general formula you should know and recognize. Left carboxylic acid, then an ester, then an amide, and then an example of phosphoric acid ester. Some of the properties and name, well, the carboxylic acid and their derivative, they undergo carbonyl group substitution. So substitution when you have one group that here they represent as the dash Z that replaces, substitute for, the group that is bonded to that carbonyl atom. So here example, ester, primary amide, secondary amide, tertiary amide. Remember, nitrogen has 3 covalent bonds only. Ester esters are routinely named by a carbonyl group substitution reaction. Look at here, you have a carboxylic acid, the acetic acid, CH3COH. Then you add an ethanol, and you are going to have the product is an ester, ethyl acetate, and water, H2O. Then the ester can be converted back to carboxylic acid when you just reverse the reaction. That's what we call hydrolysis. Hydro, water, lysis, to cut. So you have here the ethyl acetate we had as a product. You add a molecule of water, and you go back to acetic acid and ethanol.